All right, this is from our electrochemistry module. We want to know what the equilibrium constant for the reaction below is given the value for E naught. So you need the equation that relates E naught and equilibrium constant, which is capital K. There are a couple different ways it might be presented. This is the way I remember it. NF E naught is equal to RT natural log of K. That's the way I've got it memorized. You might start with a different path, but eventually we do have to solve for the equilibrium constant, so I'm going to rearrange this. I'm going to first solve for the log of K, and that will be divide both sides by RT, so NF E naught over RT. We do need the value of N, which is the number of electrons transferred. In order to get that, you look at the balanced reaction and you pick either the X or the Y in this case. Both half reactions should have the same number of electrons transferred, and figure that out. So 2X plus 3 goes to 2X. That's one of my half reactions. There's a positive 6 on the left, a 0 on the right for the charge. And so it looks like 6 electrons are being transferred. If I double check that with the other half reaction, I should get exactly the same thing. I should see that there are 6 electrons. And there are 6y minus goes to 3y2. There's a negative 6 on the left, a 0 on the right. And so again, that's going to need 6 electrons transferred on the opposite side. So n equals 6. I'm going to first solve for log of K, and then I'll take the inverse log of it once I get it into my calculator. So plugging and chugging at this point, N is 6 times my 96,500, that's in joules, times my E naught, 2.9 times 10 to the minus 1, that's 0.29, divided by R, which is 8.314, that is also in joules, that's good. I'm at 25 degrees Celsius, which is 298 Kelvin. And so if I plug that in my calculator, I get what log of K is. All right, you should be punching this in with me to make sure that you get the same thing. And I'm getting 67.77. Let me double check that. All right, I'm getting the same thing again. That is the log of K. So to get the K, I take the inverse log, the shift log of that, and I'm getting 2.710 ... times 10 to the 29th. Now I want to do a quick kind of double check of my work, and I'm going to 2 sig fig. So I type in the 2.7 times 10 to the 29. That K is larger than 1. It is a big K, which means it's a product favored reaction or spontaneous. The E naught is positive, which means it is spontaneous. That should agree. That's a good way to catch a sign error. And so there is the value for my equilibrium constant K.